In this example, we're given the graph of a function over here, and we need to determine if it is the graph of a one-to-one function. If it is one-to-one, then we need to graph the inverse of this function on the same grid. So notice we're told it's the graph of a function. How do I know if it's a function? We do the vertical line test. If a vertical line crosses the graph and at most one point, it's a function. So notice any vertical line will only cross it at most one time. But how do we test if a graph is a one-to-one function? Well, now I know it's a function, now I need to test is it one-to-one. And to do that, we use the horizontal line test. And remember, the horizontal line test says if a horizontal line can only crosses a graph at most one point, then it is one-to-one. So here's a horizontal line. If you can see, if I put it there, it crosses it one time right here. Move it down a little bit, still going to hit it one time, and if I move it even further down, notice it crosses it no time. So for any horizontal line I could draw, it's only going to cross the graph at most one point. Therefore, this is the graph of a one-to-one function because it passes the horizontal line test. So now I know it's one-to-one. If it's one-to-one, the inverse also has to be a function. And now I've got to graph the inverse on the same grid. So let me paste in a couple of sets of tables, because the only way to graph a function, the inverse of a function that looks like this, is to pick points that are on my function. And let me get my pen working correctly. I need to get points that are on my function. I need to find the x and y coordinates, and then the inverse, the points on the inverse function are going to be interchanged x and y coordinates. So all I have to do is find the points on my graph, and since this is just a segment of straight lines, I need the beginning point, which is a solid dot. What's the coordinates of that? -6, -4. So that's the point -6, -4. Let me take the next point. This is where it changes direction a little bit. If I look at that point right here, let me put a little X there if I can draw one in. It is at the point -2, -3. And then I have the point here. This is the next interesting point where it changes direction again, which has the coordinates 1, -1. And the last point I'm interested in is the last point up here. The coordinates there are 3, 5. So I have the points 3, 5. So those are points that are on my function. Now I need to have the corresponding points that are on the inverse. Remember, what is the key between functions and their inverses? Interchanging x and y. So this one is the y is going to become my x. So I'm going to have -4 as my x coordinate. -6 is going to be my y coordinate. So now the point -2, -3 is going to become -3, -2. The point 1, -1 is going to become -1, 1, interchanging x and y's, and finally I'm going to 3, 5 is going to become the point 5, 3. Now we need to graph these points, and I need to get rid of I forgot to get rid of my horizontal line, so let me get rid of that because that's going to get in the way. And let me get my pen back. Okay. So now I need to graph my points. Let's graph -4, -6. Notice I started off with a solid dot on my function, so I need to do the same on my inverse at -4. Remember, x is -4, y is -6. So I need to have a filled in dot there that hopefully it will let me keep instead of erasing. There we go, -4, -6. Slightly exaggerated solid dot. Next point, -3, -2. So here's -3, -2. I need a point there, and I think since I'm just going to put a little cross. The next point I want is negative 1, 1. So here's negative 1, 1 right here. And my last point is at 5, 3. Notice it came from 3, 5 that was an open circle up here. So at 5, 3, I also need an open circle. There we go. And so now the only thing I have left to do is I need to join these points up with straight line segments, because that was my original graph, had straight line segments between them. So let me get to my line drawing tool, and I'm going to draw from here to here, if it will let me. Here to here, and here over to here. So there, the red graph is the graph of my inverse function. Remember how we write the inverse? F with a negative 1 on it means here's the inverse of my function f. And one other thing to remember is when you graph a function and its inverse, when I graph it, they should be reflections about the line y equals x, which if I can try and get it is roughly there. It's not exact, but that's about as good as this pen's going to let me. This is the line y equals x. And does the red graph look like a reflection of the black graph around the blue line, the line y equals x? Yes, it looks like if I folded my paper down this blue line, this would lie on this would lie on this, etc. all the way up. So they look like they are reflections about the line y equals x.